Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So Alhamdulillah, from list here we have around 44 attendees. So I believe more than half you already in the session. So welcome this live session for SFS1133. And this will be a wrap up of the topic related to wave vibrations. And before we have a test and we have a break for 1 week, and then finally can continue with the optic chapter for next another 2 weeks later. Okay, so if you please check the conversation. I think everyone can access the conversation and fill up the attendance form for this session. I already up the link from at the conversation. Alright, and then you can ask a question through the Q&A. So suara jelas Okay. Okay, this session recorded. Okay. So kalau mungkin miss apa-apa boleh dengar balik lah. Alright. Okay, jelas right. So pakai mikrofon ni takut kejap on off ni. Okay, Alhamdulillah. So we start with kitab Al-Fatihah. Alhamdulillah Rabbil Alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. And for today, I hope that I can have some wrap up before your answer your test. Test senang je, insyaAllah. 20 mark. And then hopefully can wrap up a topic related to the wave and vibration before I continue for the optic. And I think you already go through all the session class lecture from the videos from the chapter 1 until 5. So hopefully this again boleh recap all the lesson that we have learned before. Okay. So Alhamdulillah, wave vibration optic, something that related to our life, and I believe that we can, after you learn this, you have expand your understanding on the wave and vibration, and also optic, because optic you didn't start yet. Okay, the chapter related to the optic. However, especially when you learn about the couple oscillation, which is more real life compared to the simple harmonic motion, then you can see a lot of different things related to the wave. And our life is itself a wave, light wave. What we try to speak right now, the wave, the electrical circuit, the electronic circuit also wave, the electron that move inside that wave, produce wave. Right now doing using the solar system, it's a wave. We have a car, the spring on the left and right. Okay, you learn about the mass spring system, it's a part of the wave. The radio, our mobile phone, 4G, 5G is a wave. And if you remember about MH370, detection on using the wave, okay, detection of wave, walaupun tak jumpa. So everything related to our life is a wave, especially because of light. So when we deal about light, so of course the wave you can learn from related in the quantum and also modern physics. You will learn there. If you related to atoms that create wave, we call it as a wave function. That will be in the quantum and also the solid state physics. And we discuss about the laser that produce a laser. That will be in continuation of the laser topic and as a subject. So this is all started to start with the what we call as a frequency. So everything that have we learned have a frequency. You're playing baseball. If you remember, because you learn about the couple oscillation, that's a part of the wave that you can calculate the frequency there. The couple oscillation, and also the second okay, golf. Okay, we can learn about golf. This is part of the wave. Okay, they can have the calculation on that for the coupled oscillation. So it's variety. There's a lot of things that we can learn, and hopefully can get the benefits. It's not directly, but those who learn, they can dapat lah kefahaman dia, insyaAllah. If you have any question, you can pop up in the Q&A session. Okay, I check if we have any question here. Alright. Okay. So for wave and vibration optics, okay. So I focus on the wave and vibration, and then optic, insyaAllah, Dr. Atirah will continue this December, okay, next month. So I just want to recap wave and vibration. For wave and vibration, so several topic that we learn is which is the basic one will be chapter 1 is simple harmonic motion. Okay, in simple harmonic motion, you already learn about max spring system and also a pendulum. So max spring system and the pendulum, we can call it as a part of the physical representation on the wave and vibration. All right. Need to change here. Sorry. Okay, so clear here. That's why what we call as a simple harmonic motion. Remember, you start with the Newton's law, and Hooke's law. And the combine of these two, you can get the frequency of mass spin system as well as the frequency for the pendulum. Yeah? Or sorry, I think better use the omega, the angular frequency. The omega, which is the omega is equal to 2 pi over T or 2 pi F. So the mass spin system, you remember, you have omega square or omega equal to K over M, and for the pendulum will be G over L. Alright, K mass spring system, K will be the spring constant, M will be mass, this will be mass, but for pendulum will be the gravitational acceleration here, and also the length of the rope. So that will be simple harmonic motion. And from this, why we call it simple harmonic motion? Because we avoid calculating the friction. So without friction, this oscillation moving up and down for mass spring system, as well as the swing from the pendulums, it will happen continuously until the end of the world. That would be the theory. But of course, we know they have a what we call as a friction. So when we call about friction, it's come up to the chapter 3. We call it as a damping. So when we have damping here, they have another equation will be minus BV, the velocity. Right? This is related to the viscosity. As actually should learn from the mechanic. and I'm not giving too much about this, but in the damping oscillation, you should know that, right? So remember, you can using the Newton's law equal to Hooke's law. This one is equal, but right now we have another minus BV. Okay, Newton's law MA. Okay, and Hooke's law minus KV. Example for my spring system. Sorry, KX. So it's equal to BV. Equal to minus BV. So we have another here MA plus BV plus KX equal to 0, which is A is the acceleration, V is a velocity, X is the distance, so that we have A is d square X over dt square, double differentiation of the distance. V will be dx over dt and X is a X. So they have some solution there, little bit complicated, which is that's why you need to learn about the chapter 2. And finally, you can get the value of X. Because the omega, basically, this we can call it omega naught, which is the omega without reflection. It will produce a new omega. And then for damping also, the value of X will be different. Okay. So compare here, we have a X is equal to A, the amplitude, cos omega t plus psi. So this the basic, okay, the basic means cos. Sometimes you can use sine. So it's still oscillation, means that the oscillate up and down. Okay, and doesn't stop. That would be the theory, because that's why I call it simple harmonic motion. It's easy to calculate, and that's happened to the system. So right now, when we discuss about damping, they have another additional things to add. So by experiment, if you would try to do the experiment related to the damping, you can put them spring here, my spring here, and put some box, metal box here, or bob. Okay, you can put inside beaker. Lupa bahasa Inggeris nama dia apa? Beaker ni. Okay, they have a water here. Okay, instead of the oscillation in the air, still have a friction, but it's very small, which is we can, if we wait until the next spring, the oscillation of the spring stop, it take 1000, okay, 1000 cycle. So if we put in the water, this will be the viscosity. So from damping, they have what we call as a under damping, over damping, but in the middle will be the critical damping. All right, critical damping. I believe you have already watched the video. They have a ruler here, and then they have metal at the bottom, and then they have magnet actually, and they have a distance between magnet and the ruler, and they try to reduce the distance, so means that the friction increase. So before this, the rulers act like a pendulum, okay, asleep until it will slowing down, guys. But after the slowly reduce the distance between the magnet here and the rulers, what happened? Maybe they will oscillate one here and then suddenly stop. So until reach one time, which is when we try to oscillate, automatically stop at the center. We call it a critical damping. So that would be something interesting about damping, and that related to the calculation. And of course, the X, okay, the graph will be something like this. Okay, I need more space here. The graph should be like this. And then they will reduce. The interesting part, the frequency is same. So what we call why the frequency is same? So because the oscillation is still the same, but the number of cycle reduce. So example, and also the amplitude reduce. So this is the amplitude. Again, this is the amplitude that reduce, but still the oscillation compared to the standard cos and sine. So right now, the gap, okay, between to complete one cycle, okay, timing example to take 1 second here. When you reach here also 1 second. Here 1 second. So F equal to 1 over T, the frequency is still same. Okay? Is it the 2 pi or what? So the frequency is still same. So means that the senggang, okay, the gap between is still same. But you can see there's certain situation that for graph, they will be shifted. So what happened here? So is the middle is here. So this what we call as a shifted. Why this is shifted? Okay, the certain value of the amplitude will be changed. So that will be effect to the system. So X, you have the amplitude exponential minus gamma over 2 cos omega t plus psi. If I'm not mistaken, gamma is equal to B over 2m. Okay, I need to check. Okay, I need to check again. B over 2m, damping. Okay, this will be the calculation that you learn for. Alright, gamma over 2t. Okay, gamma over 2t, which is a gamma equal to, where is a gamma equal to, okay, gamma is equal to B over m. Sorry, gamma is equal to B over m. Alright, this one they have t here, and gamma is equal to B over m. So what happened? They have exponential. So remember exponential graph. Okay, they have a negative here. So they have a exponential graph. So when they have exponential graph, something like this. Okay, because negative is a positive will be going up. Okay, going up. So for negative, and then the times to the amplitude. So the amplitude same. Okay, example is amplitude 1 meter. Example. But because of the exponential here, the value will be reduced, and reduced by the time. So the increased time, okay, the first few minutes, okay. So they change. So that will be the damping oscillation. Right. Next. What we discuss about, example, we can discuss about pendulum. Okay, this is a pendulum. We hold his and then we release. So the pendulum will move here and then moving back. Okay, script continue. Okay, so remember main buayan di playground, at the playground. Okay, maybe you play with your brother or sister, little brother or sister. You pull the swing, okay, and then you release. Just release. Okay, you bring a certain angle, okay, ketinggian certain ketinggian, and then you release. So okay, this it will continue swing, okay, until certain time it will slowing down and stop. So tak seronok. It's something that not challenging or not. It's not something excited. Usually what happen, either if you were the one that play buayan ke ada tak pernah main buayan. Okay, so what in the playground, what we call sometimes we use our foot, okay, to kick. Every time when we're going down, okay, we can kick so that you can go higher and higher. So when the pendulum, example buayan, move here, mana gambar tadi? Okay, here, moving here, and then bila nak patah balik, kita akan kick lagi kat tanah ni, so dia akan pergi lebih tinggi. So it can maintain to go certain high, okay. So that happen, kita akan ni. Tapi penat, yang best kalau ada orang tolak kat belakang. So keep pushing here. Keep pushing here. So we can maintain sometimes a little bit higher. So that what we call as a force, extra force, okay. So this is what we call as a force oscillation. We're giving extra force to the system instead that the system moving their own. So we have add another force. So instead we have MA plus BV plus KX equal to 0. So we know that this is a Newton's law, acceleration. We have here friction, viscosity. We have here Kx, which is a Hooke's law, and this one example for the mass spin system. Okay, pendulum dia punya calculation kadang complicated sikit. Okay, right now we have another extra force giving here. Okay, we call as a F naught cos omega t, example. So they're giving a extra force extra force. That will be interesting because, example, for mass spring system, we can give the extra force here. Okay. Pendulum also we can put the extra force here. Need to check. Okay, so I don't know how long I didn't do this experiment. So, okay, I need to change here. Alright. I need to remove. Video. Alright. Okay, so hopefully dia akan lebih clear. Ada blur sikit kat belakang tu. I need to change a little bit here. Device setting. Mana nak remove blur tu? Okay, tak jumpa pula. Alright, here. Okay, this is instead of kita lepaskan, dia akan oscillate. Okay, ni keras sangat lah spring ni. Boleh. Okay, this one is lembut sikit. Okay. Oh, tidak. Okay. Okay, instead kita okay, suara jauh sikit. Okay, tak apa. So instead kita just lepaskan. Okay, just kita lepaskan. Oh, dia macam ni. Ni cerah sikit. Alright, this one is simple harmonic motion, and also they have a damping here. Alright. So instead that kita akan beri dia extra. We can give the extra force. Okay. So extra force I become my hand, so I can give here extra force. Alright. So it will affect the mass itself. So it will affect. Tu dia dekat kelas dia seronok sikit. Kat sini dia tak nampak sangat. So when we giving the extra force, okay, of course it will affect the calculation, and definitely the frequency will change. Right? So something happen here would be the frequency. So the frequency or omega, even though omega tu adalah angular frequency, that basically we can call frequency to make it easier to understand. Panjang sangat angular frequency, which is omega is equal to 2 pi f. Okay, directly proportional. F increase, omega will increase. F decrease, omega will decrease. So nothing special, just they have additional to the rotation, which is 2 pi. Right, so omega will change. So right now they have two different type omega. Example, mass spin system, they have omega naught here, and also here have omega naught for the pendulum. This one for the mass spring system, spring. So right now they have another omega, which is we call kalau macam tadi saya punya omega, okay, which is the frequency that given to the system itself. So my omega will be different. So this is the reason for our calculation. Saya tak tunjuk calculation lagi dah, to prove that. And then everything we change using the complex function. Okay, remember complex function yang belajar x exponential I omega t, which is equal to cos omega t plus I sin omega t. Right. So we convert to the exponential, which is easier for us to solve. Sebab nanti bila nak solve nanti sama macam damping, akan ada cos, sin, ada yang cos. Sebab ini differentiate sekali 3 kali, differentiate sekali 2 kali, differentiate sekali. Tak ada differentiate. Okay, sekali tak differentiate sekali, differentiate 2 kali. So we will have the changing here. So this will be the reason we call as the frequency, and this we call as a natural frequency. Natural frequency maksudnya frekuensi asal masa simple harmonic motion yang kita buat kat atas ni, right? Damping pun ada frekuensi dia masa kita buat dia. Okay, they have a own frequency which is omega equal to omega naught berapa minus gamma square over 4, something like that. Okay, ke gamma over 4. What happen ialah kalau lagi besar frictionnya, the frequency for damping oscillation will be decrease. Sebab apa? Omega naught is omega yang asal. Ni G over L dengan K over M. Simple harmonic motion without friction. Okay. So what really happen kalau kita buat yang biasa, because the gamma is very small. It's very small. So when we minus, okay, the omega dot difference between this is very small. So nanti akan dapat omega is very near to the omega naught. Right? So that's why we can avoid the damping sometimes to calculation. But for force oscillation will be different. They have another omega that we need to deal, and I think the calculation is long and it depend on the system. So what really happened here, this is what we call phenomena called as a resonance. I think you have heard everything here, resonance. I'm not giving you the meaning of resonance, but from this system, example mainstream system or pendulum, the omega, which is the omega that force given here, kalau ada machine kat sini macam dalam buaya, okay, or given here, the omega is very near or same to the omega or SO omega OP, depend on system. So what happened? If the omega is very near to the oscillation will be absorbed. Okay, the amplitude dia memang increase very high. Okay. So this is different frequency. This is different frequency. It's omega. So if your omega here, okay, very near to the omega naught. Okay, this is omega naught. If omega here, so the amplitude will be high. So really high. So that would be what we call as a resonance. So kalau resonance, of course, explain about the breaking glass. Tak tahu ada siapa pernah try, siapa ada suara pitching tinggi boleh break the glass. And then if you remember about the tuning fork, okay, tuning fork. Saya ada tuning fork daripada lab, but unfortunately tuning fork tu sebab semuanya berbeza, so kita tak nak test. And then tuning fork dia kena ada box bawah ni. The box produce sound, kau tidak tak dengar suara dia. Okay, so the tuning fork, kita hit dengan satu tuning fork, kalau ada identical tuning fork yang satu lagi pun akan bergetar, which is because of the same frequency they have. Okay, so this become the frequency that given and the frequency that receive also same, so it creates sound. So that also we call as a resonance. And they're using also the type of resonance to tune up your, example, your guitar string. I don't know, I heard that, I don't know how to play guitar. So I believe that to tune up supaya gitar tu bunyi F not ke G ke E ke apa, G sharp, something like that. So that would be one way, okay, using the tuning fork. So that's part of the resonance, and I believe the resonance have a lot of application, and of course a lot of the disaster even happen to the Tacoma Bridge. Okay, Tacoma Bridge in New York. Even though some of them explain that it's related to the design, architecture part, okay, the design, but it still have some oscillation on the resonance. So I believe I give you a lot of videos on that, and that will help you to understand what is really resonance. Okay, that will be interesting phenomena of the resonance. Okay, saya nak check kalau ada information lagi yang berkaitan. Okay, alright. So this is some calculation. Ini memang interesting. Okay, ada yang kita dah tengok. You can see the video. I will already give you all the calculation related to the force oscillation. Next, okay, this will be last for wave aberration optic. If not, they actually if you take the wave aberration only, they have another longitudinal wave, Fourier. But for this, I stop until the coupled oscillation. So nama pun couple, okay, coupled oscillation, coupled oscillation. So means that dia ada pasangan, they have a partner. So instead of the one pendulum, they have two pendulum. Tapi dua pendulum ni buat apa? So they have certain way, ini fixed to the pivot here. So we can connect with the spring. Ni interesting, saya dah buat dalam kelas jadi. Okay, so another way actually, this one kalau nak buat dekat rumah pun boleh. You can have two pendulums connected to the another string. Okay, ada satu lagi string kat sini, and then sambung je kat sini. So dia akan melayuk sikit ke bawah lah. Right. So if you see, dia gunakan coklat kat sini pun ada. Apa nama coklat tu? Allahumma salli sama. Lupa sebab biasa kena bawa tak nampak coklat tu, nanti anak saya minta. Apa nama coklat? Selalu ada Kinder Bueno. Ada Kinder Bueno yang bulat tu kan. Okay. Ada yang kena Cadbury lah, macam-macam. So yang bulat bila ikat, dia identical ni. Kalau ada benang ke apa kat rumah, buat try. And then you can connect satu dengan satu tali juga. Kalau boleh yang sama jenis dengan ni. Kalau awak swing satu ya, if you swing one of the pendulum here, atau coklat yang you ikat kat sini, okay, by the time dia makin slowing down, ini akan start bergerak. Once dia stop, sini akan laju. And then dia akan slowing down balik, ini pun akan start balik bergerak. Dia nak stop nanti dia akan makin laju. Ini. So dia akan berbalas-balas. I can call it berbalas. Okay. So that's happen, we call as a coupled oscillation. So the calculation is a little bit complicated because coupled oscillation actually is more than pendulum or mesh spring system. You can see that here kalau dia bergelak, dia akan ada high high dengan lower punya frekuensi ya, okay. So kalau ini kita akan tengok bila dia bergerak, satu bergerak kiri, satu bergerak ke kanan with spring, okay. So dia akan satu dari lower frekuensi, dia akan jadi bergerak macam ni. Dia akan bergerak macam ni. So what will happen? Spring tadi tak akan effect, so sebab tu frekuensi dia panggil lower normal mode. Okay, ni higher normal mode. Okay, dia panggil sebagai normal mode. Alright, so this is with higher normal mode. So the spring akan access. This one that spring dia macam tak ada spring ya, tak wujud je. So that's why call as a lower mode dan higher mode. Dia ada dua mode. Kalau lagi complex, the more complex system, the more normal mode you have. Okay. And then kalau you go for ada box ni spring kat sini, and then they have spring. Ini pernah keluar soalan final dulu. Alright. So K, this one is 2K kata. Alright. M dia sama. M1 and M2 is the same. Okay, M1 is equal to M2. Okay, so dia bergerak sini, ini akan bergerak ke sini. So that will be part of the oscillation. Tu higher mode, lower mode dia akan kalau ni bergerak ke kiri, ni pun ke kanan, kiri ke kiri. So that will be coupled oscillation. Coupled oscillation is not limited to this spring. If you have rope here, connect to the ball here, and then connect another ball here. Alright. So the oscillation will be different kalau you oscillate here. Pegang dia akan oscillate. Okay. So dia akan dapat higher mode dia macam ni. Or the lower mode. The lower mode akan bergerak macam ni je. Okay, kalau kita bergerak ke kiri akan ke kiri. Ini lower maksudnya kalau kita gerak ni ke sini, dia akan gerak ke sini. So macam mana kita lajukan dia punya tangan tu, nanti dia akan bergerak lah kiri kanan. So that's why this related to the baseball, golf, something that you can calculate using the coupled oscillation. That's why the formula is quite difficult. Okay, they have some rules and regression to calculate the coupled oscillation. But this is useful. Example, ada yang engineering punya solution. You have car, alright, dengan spring. Ada lagi banyaklah benda saya tak bobol lah. Dia punya arm lah apa semua. So it's connected each other with you. Mungkin dengan satu lagi spring kat sini ke. To the car. Okay, ni tayar lah ni, tayar kereta ni. Okay, example. So dia ada calculation. How to calculate dia? Okay, so dia ada spring kat sini, spring kat sini. So to calculate dia punya ni. So example, what happened? One of my colleague actually, engineer, tapi lepas tu dia ambil theoretical physics about string theory sampai PhD. Dia kerja dekat Proton. So when Proton bought Lotus, ni bukan Lotus Tesco tu yang kereta Lotus tu macam kereta sport sikit tu. Macam Ferrari tapi bukan Ferrari. Okay. So those who knows about car, you knows about this. They have a lot something like Lotus car. So Lotus ni British. Sebab tu British marah harga Proton ni. Kita dah ambil barang dia kan. So maksudnya kita own our membeli syarikat milik British punya ni. So what happened? Lotus have good technology in term of handling. Okay, sebab dia buat pun kereta macam kereta sport car. So engineer Lotus ni, dia punya manager on the engineer ni, jumpa dekat Proton punya ni, dia bagi satu buku ni, manual. Tebal buku dia. Okay, this is a manual about how Lotus handling. Okay, you study yourself. Dia bukan dia ajar, dia bagi study. So my colleague ni memang sebab dia minat mathematics and physics kan. So dia dah study pasal relativity everything. So setakat ni boleh tak masalah lah. So that's why bila tu dia dengan a few people set up satu group untuk study buku ni pasal Lotus ni. Lotus technology on the handling. And then implement dalam kereta Proton. Right? So that's why kalau you tengok sistem ni dia bukan very simple basic system je tak. Dia ada banyak lagi benda. They have some calculation. Okay. So kalau kita corner macam mana, mana yang tinggi, mana rendah, mana yang kena sengit. So that would be tremendous mathematics inside there. So they're dealing that. Dia ada satu group memang discuss study pasal ni. And then how to implement dalam Proton punya ni. So dia kena buat simulation, dia masuk dalam software, setup. So that's why kalau siapa yang biasa bawa kereta yang Proton, bukan yang Proton suara saga yang lama-lama tu itu steering berat tu saya pakai dulu. So siapa yang bawa tu dia akan panggil dulu boleh, sekarang tu boleh pakai dah Lotus handling. So tune by Lotus lah something like that. Okay, sebab tu handling dia maksudnya kalau cornering sedap lagi pakai Proton. Compare saya bawa Honda sebelum ni pun, Honda City pun pergi balik kerja jalan tu memang berapa kali terbabas. Instead of saya bawa kereta Proton yang kereta Proton. So tak ada masalah untuk handling. Alright. So silap je dia tak buat dulu untuk tingkap je. Kalau tidak okey dah sikit. Alright. So that's I believe that this is really related to the coupled oscillation because I have a wave vibration on the engineering. Okay, dia ada engineering, ada part dia, ada mechanical engineering, ada electrical engineering pun belajar pasal wave. So I believe they related to mechanical engineering. So dia punya solution ni memang related dengan spring sini lah. Really physical. So that's why it's very tough. Tapi you belajar punya basic. And also kalau dah related to the coupled oscillation, dia akan related to the atoms. Okay, atom also have of course you doesn't see atom kita nampak kan. So usually you belajar bonding H2O H2O, oxygen here, and you have here hydrogen, okay, 2 hydrogen, alright. So this one saya warnakan biru lah for oxygen, hydrogen kita bagi warna kuning lah, hydrogen. Alright, 2 hydrogen, and this H2O have a normal mode. Okay, normal mode how dia punya pergerakan. Satu pergerakan dia adalah yang bergerak ke atas ke bawah macam sayap burung ni. Alright. Okay. So dia macam ni. Satu lagi pergerakan adalah kuncup mengembang. Macam ni dia kuncup and then kembang. Okay. So that's a normal mode lah. Dia ada beberapa lagi hasilnya. Tak silap ada 2 je yang main dia normal mode. Alright. So that would be the oscillation. That's what coupled oscillation also related to the atom. Ni baru yang ada 3 atom ni. Belum masuk yang besar-besar. Masuk catosan ke masuk silicon oxide. Nampak silicon oxide 2 tapi dia punya structure is a crystalline structure. So bila crystalline structure totally different, sebab tu dia boleh buat processor kan. Okay, so adalah atom-atom banyak sini. So this one is different rules, okay, guna. Tapi kalau yang ni untuk chemistry punya part ni, apa ni, organic, okay. So this is something like this. So this also have a oscillation. So dia akan produce macam graph, dia panggil graph frekuensi. Graph dia macam ni. Okay, absorption. Okay, absorption the frequency. So dia akan plot graph. So setiap bonding have a own frequency. So adalah dia punya frekuensi dia, unit dia apa? Centimeter minus 1 centimeter minus 1. Alright. So that should be atom. So atom level pun ada juga dia punya frekuensi and related to the couple oscillation. So that would be the related between wave and banyak lagi benda. Alright. So this will be the recap for the whole topic related to wave and vibration. So tengok ada tinggal apa. Oh, saya tak masuk yang complete function. Ini tak apa, ini semua matematik. Actually it's a mathematical that need to use to easily understand. Okay, to easily understand or easily solve the problem. Right. Bit frequency, mathematical solution but also have related. Okay. List saja saya tak belajar, saya tak fokus dengan itu. We have damping, force oscillation. Alright, so oscillation dia punya solution dia panjang sikit. They have a resonant, okay, resonant force pendulum. And then lastly couple oscillation. Oh, dia tak ada yang dah ada lukis okay. Ni damping. Okay, so this is sum up of what is a wave and vibration, and hopefully you can get a brief idea and what is a wave and vibration. Inshallah, it will help you to understand a lot of topic after this, and also hopefully you can create your assignment. Okay, lepas ni akan ada assignment, boleh check assignment dekat goals dah ada dah, boleh start sebelum you start. Ada 3 lab lagi for optic, you boleh start dari sekarang. Get idea related to the wave, vibration and optic. Alright. Any question? Soalan test macam objektif je semua. Buat kat goals je. By the time pukul 4 tu pukul 5 nanti dah boleh access dah. Boleh jawab. But once dah buka, once you open the system, automatically kena jawab lah. Dah tak boleh ni. Okay, do you have any question? You can start from the Q&A. And I'm not sure, I didn't see anyone respond from the fill up the attendance ke tak jumpa. Conversation ada tak jumpa? Kalau tak ada saya nak kena masuk dalam announcement lah. Alright. Q&A. So I will make an announcement here. Okay. I put in the announcement here. Okay, saya dah bagi link dalam Q&A. If you can see there. Okay, so nanti fill up je for the attendance. Okay, do you have any question? Untuk test teori je lah, maksudnya konsep teori. Tak jumpa dalam Q&A, saya publish dalam tu. You can check from the Q&A. Because test is objective. Kalau final exam, yes, have a calculation. Kalau test, Dia banyak konsep lah. Dia banyak konsep. Kalau yang test ni akan banyak konsep. And then dia cover chapter 1, chapter 2 saja. Right. So kalau chapter 1, chapter 2 dia adalah calculation sikit tu. Tapi dia tak adalah ni. Dia lebih pada mathematical sikit. Sebab chapter 1 dan chapter 2 so ada graf, cari frekuensi ke, something like that. Alright. Lepas ni tak ajar. Ya tak lah. Lepas ni optik Dr. Atirah. Saya optik lama tinggal ni. Okay, sebelum ni 2 subjek. InsyaAllah kalau the next ni adalah. Tapi mungkin ada sebab your batch syllabus berubah sedikit. So saya tak sure apa subjek saya akan ajar untuk your punya batch. Okay, tips formula tak payah hafal lah. Formula you boleh tulis je. Okay, tengok je. You can understand betul sebab dia basic je chapter 1, chapter 2. So saya rasa yang tough mungkin yang macam complex function tu. Yang I tu kan. So yang tu takut you kena complex function. Okay, tak apa, saya rasa kena recap sikit kot complex function. Takut orang effect pada you punya ni MCQ. Okay, MCQ nanti yang ni sikit. Okay, so saya tak banyak buat live class sebab nanti akan ada ni. Lagipun you punya video dah banyak ada dah sebenarnya. So dah siap kan. So rasa macam redundant pula. So saya better actually kalau ada request lah untuk nak terang balik. Tapi nanti saya kena check balik chapter 2 complex function. Complex function ni saya dah ada video itu. So complex function ni macam complicated sikit. Okay. So ini complex function ni memang kena betul-betul jelas, kena faham betul-betul lah. Sebab ini yang banyak soalannya. Okay. So mana X, G, Y. So ini kena clear lah kalau yang complex function ni. Ada lagi satu lagi notes tadi mana okay, ni je lah kot. Alright. Ada pakai I, ada pakai J. So basically the same thing. Okay, bye. You're welcome. Okay, kalau complex function, I believe you already have a video, so you can refer again. And if you want, you just search internet untuk cari latihan ya, contoh latihan untuk complex function. There's a lot of question on the complex function because actually the mathematical skill je lah. Okay, so soalan dia kadang matematik kalau ada ni banyak, kalau masuk yang wave tu banyak konsep, tapi kalau yang ni memang ada kira-kira sikit lah. Okay, so you need to understand vector, dia related dengan vector juga, and then dia related dengan trigonometry, ada saya tunjuk complex exponential tu, related dengan Taylor series atau Taylor ni, and then dia ada Euler relation, akan masuk real part, imaginary part, so dalam tu hanya akan solve the solution tu, right? Tapi senang je. Hafal perlu tak hafal yang hafal lah step by step untuk the question. Betul. Orang kata jangan hafal matematik kan, tapi betul first step tu memang kita kena buat banyak kali. One way that actually my dad teach me masa tu dia nak tengok untuk bantu MMAT lah. Sebab MMAT banyak soalan, kadang soalan yang pendek-pendek tu dia repeated je. So kalau kita ambil masa dekat soalan yang pendek-pendek tu, dia akan affect how to answer yang longest tu. So my dad punya tips dia lepas subuh dia kata, sebelum nak bagi mandi ke apa, lepas sarapan tu, take out one paper, kadang tu dah siap tulis satu soalan, walaupun soalan tu dah tahu jawapan, ambil soalan tulis balik. Kalau tak ingat, jenguk-jenguk sikit, betul dia balik. Okay, untuk quiz kali ni dalam 11 soalan ke 12 soalan macam tu je. Okay, maka dalam 20. Right. So to make sure kalau nak step by step tu nak clear, kalau dalam test memang takkan letak step by step sebab objektif. Tapi for preparation for your next final exam, for next subject, supaya you betul-betul faham. Test ni dalam 11 ke 12 soalannya. Check balik, ada lagi tadi. Okay, 11 questions, 20 marks, 45 minutes. Okay, tu boleh tengok, dia start 26 November 5 PM. Okay, 11 soalannya, 20 markah. So kalau nak buat latihan tadi yang tips macam mana nak hafal ke, dia bukan hafal tapi betul step by step matematik ni kadang It's not something yang normal kita buat, tapi kita nak biasakan diri dulu. Dia macam main bola lah. Takkan belajar sepak sekali dia pandai lah kan. So dia kena repeat it again. Repeat it. Benda yang sama kan, benda yang sama. Walaupun dah tahu dah, dah terror dah. Tapi kena repeat kat berlatih. Barulah betul-betul terror. So sama juga matematik ni. So cara dia buat latihan, tutup. Lepas tu bila ada set satu masa, buat balik. Mungkin ada soalan tu, tak payah tengok jawapan. Try tu buat. So it's something like macam memorize. Tapi kita nak familiarkan benda tu. So bila kita familiar, baru kita boleh cuba faham. Ingat cikgu saya ajar dulu, hafal, ada cara dia, hafal dulu baru faham, ada yang faham dulu baru hafal. So ada keadaan, macam matematik kadang tu, kita kena hafal dulu supaya kita mudah nak step by step nanti kemudian. So, okay, sama-sama, terima kasih juga, minta maaf kalau ada apa-apa kurang. Right, so step by step tu yang penting, step by step tu. Nak kena faham step by step supaya next nanti boleh mudah. Dan lepas tu baru kita fahamkan kenapa step by step ni, kenapa buat step ni. So baru kita question. Then barulah kita boleh jawab soalan lain. Nanti lagi mudah untuk jawab soalan lain. Okay, so that should be tips yang my father give me. Saya pun sekarang try kat macam tu. So tak perlu nak hafal steps tu untuk revision, tak perlulah kan. Tapi kalau final, better kena hafal lah step by step tu. Right. Untuk test tak perlu. Sebab test semua chapter 1 chapter 2 je. Okay. So chapter 1 chapter 2 tadi sikit je kan. Alright. So tu saja, kalau tak ada apa-apa soalan lagi. Thank you very much. I stay in the group, tak ada masalah nak tanya. Can communicate with me. And thank you, you're welcome. So if anything sebab final masih lagi saya masih lagi tadi So you have any question, you can directly contact me, no problem. Okay, so see you again. Hopefully next year jumpa lagi. So next year mungkin dah masuk. Hopefully ada subjek yang saya kena ajar. Saya tak ingat subjek apa saya ajar tahun depan. Ada some changing. So in second year biasanya ada satu subjek saya ajar. Alright. So see you. Thank you. You're welcome semua. Okay. Thank you. Moga semua. Okay, lebih tu. Thank you very much. Okay. Hope you can succeed. Okay. Untuk subjek ni kalau kita fikir untuk exam je memang remas. Tapi insyaAllah subjek ni takkan buat anda dapat kerja. Jangan risau. Kalau awak tanya subjek apa belajar kat universiti, wave and vibration, optik. Kebil-kebil dia. Optik mungkin, optik sebab dia ni, wave and vibration tak siapa nak ambil kerja wave and vibration kan. Tapi ingat ilmu tu dia bukan semata-mata untuk dapat kerja, tapi akan ada lebih banyak lagi benda yang awak akan jumpa nanti, yang kefahaman. Kalau awak boleh handle yang tough-tough macam ni, setakat pergi kilang bagi tugasan simple tak masalah kan. So setakat ni bila tengok nanti frekuensi, frekuensi ya. Terus benda tu dah ada idea dalam kepala kan, insyaAllah. So benda ni ada, cuma kadang kita industri kita tak akan kerja dalam bidang tu. Tapi kita anggap ilmu ni yang Allah berikan, akan ada masa akan datang insyaAllah. Okay, based on tutorial 1 yang simple harmonic motion tu semua berkaitan complex number. So macam tak nampak relation between simple harmonic motion dan complex number. Okay. Soalan ni. Okay. Okay, sebab apa tak ada relation? Sebab simple harmonic motion kita tak pakai complex number. Kita akan terus solve macam algebra punya style je kan. Kan? Betul kan? Tapi complex number nanti you akan guna bila masuk damping semua. Tapi kita boleh gunakan complex number untuk solve untuk solve yang simple motion pun boleh. Ya, cuma je dia macam nak screw tu kita pakai mesin drill yang besar nak screw driver atau pakai screwdriver. Tu je lah. So kalau faham yang complex function sebenarnya sebab chapter 1 dan chapter 2 ni is a introduction. So bila introduction kita masuk simple harmonic motion, sebab sepatutnya belajar masa intermediate atau metric, and then masuk complex function. Ada yang dah belajar sikit dan sebelum ni. Sebab apa kita nak gunakan masa chapter 3. Sama juga chapter 2 superposition. Dia nak gunakan pada chapter 4 and 5. Alright, so that's why you can memang tak nampak related between simple harmonic motion dengan complex number. Sebab kita apa yang saya ajar dalam ni simple harmonic motion, we are using directly trigonometry. Kita tak pakai pun style complex function. Cuma bila kita pergi kepada damping, memang dah kena pakai complex function. Kalau tidak susah kita nak solve. Alright so kalau tak nampak relationship dengan simple motion, betul memang sebab saya tak gunakan simple motion. Tapi saya ada tunjuk juga sistem untuk solve yang simple harmonic motion guna complex function ada juga. Saya ada tunjuk kalau dalam tu ada. Kalau tak ada nanti kita buat satu kelas lagi lah. Kita akan cover ini balik sampai motion. Kalau perlukan nanti beritahu, nanti kita buat lah sesi ni masa lab ke kalau you are free. Okay, so dia tak ada, kalau tengok dalam video, dalam slide ni pun dia boleh solve dengan sifat motion tapi dia lagi panjang, macam complicated sikit, padahal benda ni simple je. So masih boleh gunakan. Okay, harap menjawab soalan. Doktor tanya, assignment tu kan kena berkait dengan wave, vibration dan optik atau salah satu daripada tiga tu? Salah satu. Tapi kena ada integrasi of nuclear and nuclear. Itu wajib. So that's why kalau yang you tengok dalam goals, ada video minggu ke-8. Itu talk daripada Datuk Naib Chancellor. Actually ada link Facebook dia, boleh check. Saya nak cari video dia tak jumpa. Saya upload dalam YouTube, saya dapat download dan upload YouTube. Jangan share banyak-banyak tempat ni. Upload secara haram ni. Cuma mungkin sebab dia ada isu patut dia tak upload dalam USIM punya YouTube pastinya, sebab ada Datuk NC letak petikan ayat Quran bacaan Syekh daripada Mekah lah semua kan. So benda tu rupanya ada license. So tak boleh nak, kadang ada sangkut sikit lah publish. So nanti you all tengok video tu untuk kefahaman. Hari tu pun dah dengar talk hari tu so saya rasa Datuk NC punya talk tu memang very, yang kata apa, memang komprehensif. Walaupun cerita soal An-Nur banyak kita dengar banyak kali dah, tapi bila Datuk NC ceritakan berkaitan dengan wave tu, dengan cahaya, dengan gelombang tu, Allah Akbar. So lain juga dia punya ni. So alhamdulillah kita tak jumpa orang yang boleh ceritakan macam tu lagi. So bila kita dah ada dan Datuk NC pun banyak lagi, tadi pun dia ada bagi talk sebelum solat Jumaat, siapa yang kalau ada kat USIM dia dengar tadi. So cahaya dan kegelapan, saya pun termiss tadi, saya tak boleh dengar dia. So hopefully nanti bila dah dapat buat assignment nanti, anything, wave ke, vibration ke, optik tak masalah. Alright. So dia tak nampak ada relation, jadi actually sebab basic ni mesti sama lagi di tiga tu. Okay, salah satu je tak apa, tak masalah, wave ke, vibration ke, optik ke. Alright. Ada lagi ke kalau yang tadi tak jelas tadi ke? Kalau yang apa complex function tadi, doktor boleh jawab test sampai 15-12 kan, tapi dia close on Sunday 28-11. Alamak, ya ke? Sunday tu yang lama. Sekejap ke saya lupa nak adjust setting dia. Saya baik ingatkan. Timing. Lah, close 25 November. Sepatut tadi berapa tadi Disember? 5 Disember. Ya Allah, ya Tuhan, aku tak tukar aku punya. Okay. Nanti okay dah set dah. Save. Tak boleh attempt sekali je Save and return. Alright. Okay. Dah, okay. Thank you. Dayana Batisha tu kan. Okay, thank you. Saya dah adjust balik tak ada benda tadi. Betul, yang paling penting kami kena fokus untuk revision for test ni complex function. Betul. Yang tough sikit, yang ada calculation sikit, complex function. Okay, complex function tu akan dia sebenarnya soalan basic je sebenarnya, tapi dia akan mengelirukan lah. Tengok siapa buat soalan ni kan. Okay, tapi kalau yang pasal simple motion tu ada sikit-sikit. So dia ada soalan yang tricky sikit nak cari faham konsep. Tapi tak banyak, sebanyak yang complex function ni banyak. Okay, adalah sikit yang supervision sikit je. Okay, ada apa lagi persoalan tentang test? Okay, assignment dah ada tadi, assignment test. Assignment tadi buat infografik je kan. Tengok dalam goals ni macam mana. If you have any problem dengan goals, maklumkan kat saya. Kita kena tengok macam mana kalau instead of the tiba-tiba nak upgrade lah apalah kan. Tiba-tiba satu minggu ni off ke, kita pun tak tahu. Hari tu tiba-tiba kan. Alright, kalau tak ada apa-apa soalan, saya tengok dalam group WhatsApp ada lah. Fill up attendance. Takut siapa yang terlupa nak fill up attendance. Tak ada dah, okay. Alright. So, untuk makluman kalau dalam minggu ni, minggu depan ni, pensyarah semua sibuk dengan buat soalan final ni. Soalan rating, soalan final. Soalan final sebenarnya siap dah pun. Okay, so insyaAllah hopefully kita akan jumpa semester akan datang. Okay, physically meeting dekat USIM lah. Bukan online lagi. Saya pun kalau jumpa awak tak kenal lah. Memang tak kenal. Okay. So jumpa lagi insyaAllah. Kalau apa-apa boleh contact insyaAllah. So Assalamualaikum warahmatullahi wabarakatuh. Kita akhiri dengan tasbih farah dan solat doa. Okay, recorded biasanya dalam Teams ni. Oh, yang takut you tak access kan? Okay, nanti saya download dan cuba upload dekat YouTube kalau boleh. Okay, Alhamdulillah, thank you very much. Okay, so nanti kalau boleh nanti saya akan upload dalam YouTube dan akan letak dalam goals. Oh, nanti baik ingatkan. Okay, you're welcome. Okay. Okay, saya akan live now. Assalamualaikum.